Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about what is a transaction, what are the concepts behind a transaction, and how we can define the transactions with the acid properties like the atomicity, consistency, isolation, and durability. Finally, we will take an example and then see what the properties can be satisfied on these transactions. Often we know that a collection of several operations are put together to complete a meaningful task. Say when we are performing an airline reservation from the starting from the site which is opening in front of your desktop, then you need to go to the select dates section. After that you need to select flight section. Then you will be open within select seat page where you can select your preferred seats, and then you need to complete the payment section. So all these operations are completing your transaction of an airline reservation. You cannot just do a single task on to complete this transaction. So whenever the term transaction comes, it is a collection of several meaningful operations that is collected for a logical work. Now, when we are talking about a logical work, that means it is not that you are putting some operations that are related to each other, but together they will not make any logical task. Say for the payment page on this airline reservation and this seat selection for a cinema booking, and there is the site opening and date selection for some other train booking. So all these tasks are related with each other, but if they perform together, they will not do a logical task. So we need to combine those tasks inside a transaction that will perform a definite logical task. Now, the transactions are generally written by declarative languages like SQL or a structured query language, or either we can write it like this high-level programming languages like C, C++, Java, and connect with this JDBC and ODBC connectivity to connect with the database. Now, when we perform this type of functions, we need to transaction complete our form begin transaction and end transaction. When we are making something inside this form begin and end transactions, that means we are stating that the operations belong to a single transaction. Now we can name this transaction as begin transaction, transaction name, and only end transaction at the end of the transaction. So now that we have known what is in form of a transaction and what does a transaction do, but for doing a complete transactions, we need to follow a set of properties. That properties is popular with the name of acid properties, where ACID go for 4 properties with this transaction. The first one is in atomicity. When we are talking about atomicity, that means the atomic, all or none property of a transaction. If you are performing some set of operations that will do a single task, then you need to perform those operations in such a way that either they will be performed at all or it will be considered that they are not performed. Cannot be like this, some of the operations are performed and some are left to complete a transaction. We cannot just complete a transaction without performing all the operation in the exact sequence they are being written in this transaction. Like you cannot do the payment section first and then select your seat. It comes in an order that we follow for a complete transaction. So when we are performing these operations in a sequence and in a complete sequence, then only we can say that the transaction is complete, and this property stays for this atomicity property. That is, we cannot break the transactions in further sections where it is considered to be an atomic. So a transaction is a single unit thus considered to be atomic. So the operations are the part of the transactions we are not considering as a separate unit of work for this transaction. So now if we have clear with the idea of this atomicity, we will move to our next section, that is consistency. The acid property C sat for consistency. When we are talking about consistency, then we are actually referring to some persistent data. Now, what is inconsistent or persistent data? That means if the old value that we are pertaining from our selection and the new value by updating the site, then these two values must be related with each other in some logical way. Now say for again the airline reservation system, suppose that a user just log into his account, select the dates, select the flights, goes to the select seat section. But after then he can see that there is no preferable seat for him or her. Maybe he selected one or two seats, go to the payment section. Now he found that something problem with this payment section. So now the selection of seats will again be back to the previous selection that was not made by this user. That means if there are 39 seats available before the transaction, there should be 39 seats available after the transaction too, because to support the atomicity of the transaction. Now that we have taken that all the operations are not operated each other within sequence, so that transaction is not complete and it is also not consistent. So either a consistent transaction make a successful update on the new part on this transaction, otherwise it will pertain its old value. That means the value will persist even if the transaction is not completed or aborted for some ways. So that goes for the consistency state. So the consistency property is generally built on the property that is atomicity. If it is atomic in nature, then it will be by default consistent for a transaction. Now when we are performing in concurrent execution, then consistency become absolutely important, because it may happen that one part of the transaction needs the result of the other part. So if they are not performing in a consistent and atomic way, then the concurrent execution will fail for the transaction. Now we will go for the next one, that is isolation. We know that for a transaction, it is actually using or accessing only a part of the database. Rest of the database are there for other transactions or for just storing the data that the user intended to store. Now, what happens if a transaction that is concurrently executing with other transaction tries to access the same data at the same time? They will definitely go for an inconsistent result, that which is not desirable. So the isolation is important, that one transaction will perform in an atomic way or in consistent way, isolated or separated from other transaction. Like when the transaction is performing, no other transaction can perform on the same part of the database at the same time. Either they need to perform it in a sequential way, or if it is an asynchronous transaction nature, then it must access the other part of the database, not the same part of the database. So that stands for isolation. So the isolation has two parts. First one is a transaction must be separated from each other, and the second one is they must perform in the same part of the database in different times or different part of the database at the same time if necessary. Now what we are talking about, that same part of the database it cannot access, it also a part of this isolation property. The last one is durability. That means it is a by default result of a consistent database. Durable means the result that we are pertaining from a transaction complete or a transaction abort is durable. It will be not lost for any of the sake on a database lost. So when we are storing the database to some disk or to some secondary memory, because primary memory we consider it as a volatile memory and also a non-stable storage of memory. So if we store this memory as a part of this database or hold the database in this type of memory, then there is a possibility that we will lose the data, because this problem arises of losing this storage frequently rather than having it in a stable storage. So what do you mean by a stable storage? The stable storage stands for where the data will be not lost even if the power gets down or there is some hardware and failure problem. So now we can consider the secondary storages, the flash drives like pen drive, CD drive, as this stable storage, because we can store our database in this hard disk or this secondary memory to our safe consideration and to make the result durable. That is, even if there is a problem with the primary database storage, we can fetch the data from the secondary storage. So now whenever we need to access a part of this database, then we must fetch that part from the disk to the main memory, access the data, modify the data, and then update the result back into this disk storage. Now we can see that we can arrive in a consistent state whenever there is an updation on this data and the updation has been reflected in the disk storage before the transaction is completed. Now if the transaction is having some updates on it and the updates are being performed, but still there is some properties or some operations left to complete the transaction, whenever there is an update in the transaction on the part of the database will be updated only at that point in time immediately. Now by this one, if we are having, we can maintain the isolation and also the durability of result. Now we can see that all the properties are related with each other, that some properties are a result of another property. Now how a transaction maintain these properties? We can say that the transaction maintain these properties by having some good features on the database. Like if we maintain a log record, that what are the old values that we are having before the transaction for the part of the database in a log, and then compare the value of this new part on this updated transactions, then match these two values. If they are related in a logic in some manner, then we can consider that the transaction has been recovered or the transaction is now complete in a consistent and durable manner. So these good database features are allowing us to maintain these properties. Now let us take this example and see that how the properties on this transaction are maintained. Say for an example, if the transactions having that a transaction of accounts A and B, that B will be deducted with $50 and then write the value to it, and there will be an A which will be given this amount $50 and it will be write to it. So for our transaction that we are considering, we will take two operations, one is read, another is write. So when we are saying this read X, then we are mentioning that we are fetching data from the disk, storing that data into a variable X, and then reading the value for any modification or the updation of data in our transaction. So when to perform this account transaction, we must fetch and read the data of account B first. Then we can do this B equals to B minus $50. And finally, we can write this B. So what do you mean by an write account B? So writing to an account or a variable means write X function. So the write X function go for the variable X, take the value and write it to the database back. So now we will write it back to B. After that again we will read the value of A plus the amount $50 to A and write the value of A. Finally, we will display our A plus B, that what is the sum to check the consistency. So this is our basic transaction on which we will follow these properties. Now first we will talk about this atomicity. What do you mean by an atomicity in these transactions? Atomicity means whether we are having 2 or 3 accounts. For example, here we are having 2 accounts. The 2 accounts will be updated at the same time. We are considered that the transaction will be completed when there will be a deduction from account B, and also there will be a credit to account A. So we cannot have just this debited from account B and credited to account A in any of this operation that is performed in a separate way. So we need to perform these operations together, then A and B, so that we can follow the atomicity property of this transaction. The next is the consistency. Say for an example that we have not maintained the old values on this A and B. And suppose that our account B has $1,000 and A has $2,000. Now we have subtracted from account B, that is the first part of the transaction, reaches to there at $950. Now what happens that the transaction fails for some reason. Now my $B is being updated with a value 950, but A has not given any plus $50. So A is remaining its old value, that is $2,000, and B becomes 950. So now if we perform display A plus B, it will be 2,950, where the old values were to display A plus B is 3,000, that is 1,000 plus 2,000. So how we can reach this consistency between this transaction? One way to check for the consistency is that to check the unchanged result of the old values and the new values. That means in some way if we perform a calculation on the old values, the result will be unchanged as a whole total for the new values. That means if we perform display A plus B before the transaction and after the transaction, both the value will be same result if that is a consistent transaction. Now if the transaction is not consistent, then we can reach in a result which will give us two different one from the old and new value calculation. So now we can check for this consistency of having this display A plus B and the new value of A plus B. So how can we maintain this consistency in this transaction? Another way to perform is to perform all the writes at the end of the transaction. Say suppose the same transaction, if we have modified in this way that we have read the value of A, perform this B equals to B minus 50, read the value of A, perform A equals to A plus 50, and then perform write B and write A. Now if there is a failure after B equals to B minus 50, so now it will be not affected in the transaction or the database because we have not written the value to the database back until we are committing the transaction. So one way to perform this consistency, that is a recovery technique, to add this write transactions at the end of the transaction when the transaction is about to commit. Now the two things can we do, that all the updates that we are maintaining for a transaction must be updated or modified the database immediately when it is facing to the transaction, even if before the transaction commits. The next is whenever we putting information into the database, that must be sufficient for the disk to get the information out of the database and to make the update to the database. So if we can perform in this way, then we can maintain the consistency. Now see, the consistency will be resulting in an atomicity. So if there is a consistent state that we want to reach, then the transaction must be atomic. That means all the transactions that are performing should be considered in a single unit. Now even if the transaction fails between these operations, then we will restart this transaction by rollbacking it. What do you mean by rollbacking the transaction? That is also a recovery technique of a transaction, that we are reaching in a state where the transaction has successfully completed its operation and the updation of that particular transaction till that point will not affect the next part of the transaction. So either we need to roll back the transaction or we need to restart the transaction. In the extreme cases, we need to just abort the transactions and start it from the fresh. Now in this way we can perform the atomicity and consistency. Now what about the isolation? If we are performing isolation, that is one transaction that different from other transaction. Say for an example, if a transaction on this two account A and B that we are considering as an example, one transaction is performing the read B, B minus 50, write B, read A plus 50, write A. Another transaction is performing display A plus B. And after that, there is some updation to the A and B for the transaction 2. Now, if these two transactions are concurrently executing, then it will must give us an inconsistent result. Because first, if the display A plus B arise in somewhere between this read B and read A, then it will give us an erroneous result on this B and A. Maybe the B is reading as the old value and the A is reading as a new value, so it will give us an inconsistent result. But concurrent execution sometimes becomes necessary and important for us to perform. Then we need to take some recovery technique to perform the concurrent executions. That we will discuss later, but today we are discussing about isolation. That means the transactions that are related to the same part of the database must be performed in a sequential order. That first we are updating the transaction T1 on this account, and then we are performing the display transactions on this account so that we can get a better result. So the isolation stands for if there are two transactions Ti and Tj belonging to a schedule, then we must perform that either Ti is performed and executed completely before the start of the execution of Tj, or the Tj has successfully completed its transaction and after that Ti is starting. So this way we can perform the isolation property maintained in this example. The last one is durability. Durability stands for what we are discussed previously, that the result will be updated back to the database and the database is now stored in a stable storage. For example, that we have fetched the data from account A and account B from the disk to our main memory, has performed this updation to this account and then storing the result back to the main memory. Now what happens if the data we are not storing back to the database? We have written it to the variables, but the database is not updated on the disk. Now when there will be another access to this part of the database from the disk, it will give us an inconsistent result. So not only the atomicity but the durability is also linked with this consistency, because we need to store a durable data that is stored inside in secondary storage or any persistent or stable storage. So by this way we can perform these four properties related within transaction to make a transaction complete successful. Now after that a transaction is completed with its successful completion, then we can say that transaction is committed. Committed means the transaction has successfully finished all the operations in a given sequence in a successful way. So that is all for the transaction and its properties. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.